So talking about data link layer protocols, there are two data link layer protocols, simple and what to say. Wait. So first, what is data link protocol? We have already defined these topics in almost all the videos. I mean, related DLL. So it's nothing but controlling how the data is transmitted correctly. It should be transmitted. Manage error control and flow control and framing also of the data. All these things we have to just talk in the definition. Simple protocol. Nothing but here it's very simple. Both the senders and receivers are in a ready state where when the sender gets the data, he just transmits what to say receiver and receiver one by one it will do. Okay, it will receive, acknowledge it, and then again the sender sends the what to say like that. So just read once the simple the most basic data link protocol where frames are transferred in one direction with no error or flow control mechanism. So here error control and flow control mechanisms are not there. Simple way. So sender gets data from network layer, organized into frames, sends to receiver. Receiver gets the data from sender, processes it, sends to network layer. Simple. Then stop and wait protocol definition you can see here. It is used in data link layer communications to prevent buffer overflow at the receivers. So here main thing it is uses to prevent the buffer overflow at the receiver and ensure reliable transmission. Same we have yesterday, right? So it's like buffer space will be there for both sender and receiver. So the sender will send the data until it receives an acknowledgement from the receiver. It won't send the next data. Okay. So see the sender sends a frame and waits for the acknowledgement. Sender sends and waits, and what the receiver tries to process the data and sends an acknowledgement that it has been the frame has been acknowledgement. If the sender is not sending the acknowledgement, so the sender is humble enough to assume by himself that the frame was either lost or corrupted or something discarded, so it will send out the frame again. The acknowledgement is not received due to frame loss or corruption. The sender resends the data frame after after the timer expires. The receiver checks for errors. If the frame is error free, it sends an acknowledgement. If there is error, then it will just discard and acknowledge it is not sent, and after the timer again the frame is sent. So it has flow control and error control. You can simply talk about flow control and error control. I need a mechanism like that, CRC, and that automated repeated checks. Then key points, see, simple but inefficient for high-speed networks due to its wait time for sending each frame. Ensures reliable data transfer through retransmission and acknowledgements. Then here we have another type of DLL, that is sequence and acknowledgement number. So in sequence and acknowledgement number, what happens is basically, so whatever the frames are being transmitted are numbered, like given some specific numbers in order, so that whenever they are sent, the receiver receives that, so it will identify which the frame has received. If the frame 0 is received, then it will send an acknowledgement for frame 1. So it's just, if you read this, it should be enough for you to understand what is this sequence and acknowledge number. So it is used for handling handling frame identification and to manage loss or corruption communications. So see, frame identification is one keyword, and manage loss or corrupted frames is another keyword. So sequence numbers are given. Acknowledgement numbers is whatever the frames is required next. The acknowledgement was given. You can simply give an example saying how if 0 is received an acknowledgement, so it will send an acknowledgement for next frame, that is 1. Sometimes frames will be missed in the middle or gets corrupted in the middle, so it will again recheck the order 0, 1, 2, 3, 4, 5. So 3 is not there, so it will send an acknowledgement for that and reorders it again. Piggybank is nothing but whatever the data has been sent, it will just combine the data of two nodes by sending an acknowledgement. So sending the data A and B. So the node A, what it will do, the frame, it will acknowledgement for the data from the node B. So reducing that overhead by combining data and acknowledgement in one frame. So before going to point communication, let us see the diagram here. See, simplest protocol. So network layer, data link layer, frame and logical link. So between the sending and receiving is a logical link, and the frames are being sent. This simple, very. So network layer, data link layer. Layers are there. Logical link is there. Frames are being transferred. Talking about see, this is an FSM finite simple state. I think the full form is here. Finite state machine diagram. For this, you can either draw this or see packet came from network layer, make a frame and send it. So start sending node. So it's transmit. So you can simply say that it's transmitting the data like this. Here it receives, it processes it, and delivers back to the network layer. For stop and wait, so you can see this diagram. Wait, I'll just say for stop and wait, yeah, you can go for a good diagram, but okay, fine. We have here like this. So sending node, receiving node, time packet. So it sends one. See, sending node first. It takes packet comes from network layer, makes a frame, saves a copy, and sends the frame. Starts the timer. So it will go there. So timeout resends the frame, restarts the timer. Corrupted acknowledge the acknowledge. Error free acknowledge arrives, stops the timer, discards the saved frame. So in the sense here this will be added here. Okay, receiving node. Corrupted frame arrived, discarded the frame. Again it will start. Error free frame arrived, so it will send the acknowledgement. So here this thing is here actually. So from blocking you can simply add to like that. Or if not, if you see your textbook, we should have a proper how to say diagram also for that. We can either draw this, see, or just we'll move for next. About piggy banking is also a small thing, so we can go for point-to-point protocol. So you can see here all these names and all, right. So this you can simply write specifically separately. You can see here now. So it is a widely used data link layer protocol designed for point-to-point communication, such as connecting homes computer and ISP internet services. That is Wi-Fi out and other things. So key features are nothing but the framing, address field, control field, protocol field, payload field, error control, and byte stuffing. So point-to-point communication uses byte-oriented frames. So it uses byte-oriented frames. You can again talk about that byte-oriented topic in the previous videos. So for the starting in the Arduino frame, it will be having synchronization pattern. Address field, address constant value of an broadcast. Control field set to a constant value to imitate unnumbered frames. Protocols are used to say specify the protocols being carried for payload field. Payload field carries the data typically up to 1500 bytes, and the byte stuff contains a flag. Error control is there, byte stuffing is there. So these are the five phases: dead state, established state, authenticate state, open state, and terminate. No active communication. Established means communication is initiated and options are negotiated. Authentication, if needed, authentication is performed. Sometimes it might be required. Open state. Data transfer takes place. Terminate state. Communication is terminated. So you can write the key points for this. Whatever it is, supports point-to-point communication over serial links. Includes simple with error detection and optimal authentication. See, additional thing has coming. So authentication uses byte stuffing to prevent flags of the data section. So if you have to remember key points, before that we'll just see this thing. See, flag, address, control, protocol, payload, FCS, flag. So same thing is there, right? You just have to explain this again. So this field has a synchronization pattern flag. The field identifies both the beginning and ending of the frame. Address, the field is set to a constant value. All are ones. Control, this is set to constant value. All are 0 except for last two. Protocol, it defines the protocol carried by the payload field. Payload field carries either the user data or other control information. 1500 bytes up to. So byte stuffing, we have to talk about byte stuffing, which we had talked about. Then other phases, all said in dead state there are no active carriers and the line is quiet. Established state, when one or two nodes starts communication, the connection goes into the established state. Authenticate, if two parties agree that they need authentication, then the system needs to do authentication, otherwise a party can simply start communication. So authentication like Google Meet, you have to admit, right? So I sent a link for Google Meet until you cannot join, right? So that's like authentication. Terminate state. So here is a diagram, transition phases diagram. So see, open, terminate, dead, establish, authenticate, and so diagram for point to point is this. So two diagrams are there. You can easily write this and remember. So I hope you a good understanding for this topic and just subscribe and like the video.